All right, today we're going full on cosmic detective. We're opening up a case file on, well, one of the absolute biggest and most mind bending mysteries in the entire universe.
Yeah, I know, that's a massive question. But what if I told you there are places out there? Places where the very rules of physics, everything we think we know, just break. Like reality itself just hits a dead end.
So let's investigate, you and me. We're going to follow the clues, look at the evidence, and see if we can crack this thing wide open. Okay, so who's our main suspect? We're talking about an object with gravity so powerful, so intense, it pretty much shatters our whole idea of common sense. This thing is a legit cosmic monster. Just let that sink in for a second. The fastest thing there is, light, can't even escape. It gets trapped. So it's not just dark, it's like a cosmic trapdoor, a one-way ticket to, well, we don't know where. And that's the signature of our culprit, the black hole.
Now, I know what you're thinking. This all sounds like something straight out of a sci-fi movie, right? But here's the crazy part. The first clue, the first hint that these things could exist, didn't come from a wild story. Nope. It came from our deepest, most profound understanding of gravity itself.
Okay, think of it like this. Imagine space-time is a huge, stretchy sheet, like a trampoline. Now, if you put a baseball on it, that's kind of like Earth. It makes a little dip. Put a heavy bowling ball on it, that's the sun, and you get a much deeper curve. But a black hole, man, that's like a tiny, impossibly heavy pinhead that just rips a hole right through the fabric. That's the core idea behind general relativity. And this idea, it took a while to cook. It all kicked off back in 1915 with Einstein and his game-changing theory. But then, get this, just 1 year later, a guy named Carl Schwarzschild is playing with the math and finds something weird, a singularity, a point where the equations just go haywire. For decades, it was just a mathematical curiosity, until 1967 when the physicist John Wheeler gave it that perfect, spooky name we all know today, the black hole.
Okay, so we've got the backstory. Now let's get our hands dirty and dissect this thing. What exactly is a black hole made of? Let's look at the anatomy of our culprit. Right at the center, the absolute heart of the mystery, is the singularity. This is the point, literally. It's where every single thing that falls in gets squished down into a space so small and so dense, it's basically infinite. This is the spot where our understanding of physics just completely falls apart.
And wrapped around that singularity, you've got the event horizon. I love this analogy. Think of it as the lip of a giant cosmic waterfall. You can get closer and closer, but the second you drift over that edge, that's it. You're gone. No engine in the universe, not even light speed, is fast enough to fight that current. It is the absolute final point of no return. And that really highlights just how bizarre these things are. I mean, think about a star. It's a furnace, right? It's burning fuel, pumping out light and heat. A black hole is the exact opposite. It's a consumer. It just eats. It traps everything, even light. One is a cosmic lighthouse, and the other is the ultimate cosmic void. Which, of course, leads to the big problem for us detectives, right? How in the world do you find something that's literally invisible? I mean, it eats light for breakfast. You can't just point a telescope at it and snap a photo. Or can you? Well, you have to be clever. You look for the chaos it leaves in its wake. It's cosmic forensics. So first, you watch how its immense gravity yanks on nearby stars, making them dance around nothing, an empty spot in space. Then you look for the screams of matter as it falls in. The stuff gets superheated and blasts out X-rays. And the final, incredible step, you try to take a picture of its shadow, its silhouette against all the bright stuff behind. And here's the thing. This isn't just a theory anymore. We have the evidence. The smoking guns are all there. We've watched stars at the center of our own galaxy, whipping around a supermassive something we can't see. We've seen those glowing, swirling disks of gas getting devoured. We've even seen how their gravity bends light from behind them. And the absolute clincher, we have an actual picture. The Event Horizon Telescope captured the shadow of a black hole. So case closed, right? Well, not so fast. Yeah, because like any great mystery, the moment you solve one piece, you realize the puzzle is way bigger and weirder than you thought. We've found our culprit, no doubt. But understanding what makes it tick, that's a whole other story.
And this is where we're at the absolute edge of what we know. See, to figure out what's happening inside a black hole, you actually need two different sets of rules. You need Einstein's general relativity for the massive gravity part, the physics of the huge. And you need quantum mechanics for that tiny, super dense singularity, the physics of the super small. The problem? Our two greatest theories, they hate each other. They give completely different answers for what's going on in there. The rulebook for the universe just stops working.
Which leaves us staring into the abyss, asking that one last epic question. What actually happens when you fall in? What's on the other side of that event horizon? Is it just the end? Or a new beginning? Maybe a doorway to another universe? Who knows? That's the part of the file that's still wide open, and it's just waiting for the next big breakthrough, the next cosmic detective to finally crack the case.